As you've probably noticed, the title of this section has changed to Should Trunking Negotiate, but everything else is exactly the same. So when you saw, I believe it was, to trunk or not to trunk or something like that at the end of the previous video, you didn't miss one, we didn't skip one, I just changed the title for the book. Now, for this section, what I did is I erased the previous switch configs, reloaded both switches so they're now running both entirely at their defaults, except I did add VLAN 12 back, so we're going to see that with a couple of commands. But our native VLAN is back to 1 and everything else has been reset as well. Now I'm going to bring the live equipment up because I want us to see a couple of differences here between the two switches. And I want to see if I can't get all this on one screen. It's going to be close. Okay, you'll have to take my word for it that switch 1 show interface trunk is right there. And then I want to compare these two because on switch 1, we see the ports that we expect to see. And then we have a mode, a trunking mode called desirable. And then our encapsulation is 802.1q. All looks good to us, and status trunking, that looks fantastic to us. We love that because the options here are trunking and not trunking. And our native VLAN, of course, is reset to 1 because of the reload, and the write erase, I should say, and then the reload. So we've got that running. Now on switch 2 for the trunk, same two ports we've been using. The mode is changed to auto, though, on switch 2 as the default. That's a little odd, especially for those of you who have learned the theory that dynamic desirable is the default for all Cisco switches as far as trunking mode goes. That was true in the past. It is no longer true. That's why I like to use two different switch models in this course, so you can see two different switches, get used to that for the real world. Now, speaking of different, for encapsulation, we've got the letter N and a dash in front of 802.1q. So is that some kind of variation of 802.1q? We're going to find out in a minute. It looks good, though, because the status is trunking, and we like that. And, of course, that native VLAN is set to 1. Before we talk about that letter N there, let's review our trunking modes. Now, trunk mode, of course, is unconditional trunking. There's no negotiation necessary. It's going to trunk. Dynamic desirable, that's going to be shown as desirable in show interface trunk. And it means the port is actively attempting to form a trunk with the port at the remote end of the point-to-point connection. Now, if the remote port is running trunk, desirable, or auto mode, a trunk is going to form. And that's why here I didn't have to do anything as far as configuring the switches to make this trunk work. I have two crossover cables. We talked about using other cables to be auto-sensed, but I've got a couple of crossovers. They came up. Switch 1 is in desirable mode. It's actively attempting to trunk on ports 11 and 12. Over on switch 2, the ports are running in auto. It's kind of the wallflower of trunking modes in that a port in auto mode will not initiate trunking, but if the remote port initiates it, the auto port will say, okay, the remote port has to ask a port in auto mode to dance. That's really what happens there. Now, that N in front of switch 2, that means the encapsulation type was negotiated rather than hard-coded. Okay, that makes sense, but oddly enough, switch 1 didn't show the encap type as negotiated. And here's why, and this drove me absolutely crazy when I got my first 2950 switch from my lab years ago, and that's what switch 1 is. And the problem comes in whether the switch is capable of running ISL and .1q. It's not a problem as much as just a differentiation. Switch 2 can run ISL and .1q, and in that case you can hard code the encap type with switch port trunk encapsulation. And I'm not actually going to change the encap type, but I want you to see the command and see the options here. And we'll go to port 11. It's switch port trunk. And here you'll notice I have 4 options. I'm going to move that just a bit. There we go. I have 4 options for switch port trunk. I have allowed, encapsulation, native, and pruning. And they're exactly what they sound like. The allowed option, we're going to hammer that one in the very next video. Encapsulation, we're talking about that one now. Native, we used that one for the native VLAN, to change the native VLAN in the last video. And pruning, we'll talk about that in the VTP section. But switch port trunk, so then if I use encapsulation here, then there are my options that I would expect. .1Q, ISL, and negotiate. I'm either going to choose one of these two protocols or I'm going to let the port negotiate it. So everything's fine and dandy there, right? And that's why we see the N on switch 2 in front of 802.1Q. Now, the CCNP switch exam is not going to get into details about which switch model can run both protocols and which ones can't. I just want you to see this real world and know exactly what that N stands for. I also want you to know in advance that, like I said, this drove me crazy the first time I saw it, and I know that explains a lot, and I want to spare you that fate. So let's say that I just got this switch and I'm all excited. I'm running some commands. And I run switch port trunk, and I don't have the encapsulation option. Allowed, native, and pruning. We saw all those on switch 2, but we don't have the encap option here. So I was probably just being hard-headed as usual, put encapsulation anyway, spelled it correctly, and unrecognized command. Now I'm always telling you to remain calm, but there will be moments in networking, whether you're in production networks or studying for an exam. And unrecognized command, you know what that is most of the time. You probably did that a lot in your CCNA study. I certainly did. You're just in the wrong mode. You're putting a global command in interface mode, or you're in interface mode and you're trying to run a global command. It's not going to run there. So that's not the problem here, though. The problem is that switch 1 is a switch model that cannot run ISL, and there are plenty of those. It can only run 802.1Q, therefore that option is not even here to change it because I can only do one thing. So that again, and I just want to show you this one more time. That's why you don't see an N in front of 802.1Q for encapsulation on switch 1, because it wasn't negotiated. It's the only one that the ports can run. But if I run show interface trunk over here on switch 2, you see the N for negotiation because you can change that type. Now let's talk about DTP here for a few minutes, and then we're going to run a lab on that as well. Because the dynamic trunking protocol, DTP, it handles the actual trunk negotiation workload. This is a CISCO proprietary protocol. It's also a point-to-point protocol, as we would expect. And it is going to attempt to negotiate a trunk with that remote port. Now, as with everything in networking, what we already said a couple times, everything comes with a cost. DTP's cost is that a port running DTP is going to send DTP frames out every 30 seconds. That's almost RIP-esque, right? Remember RIP version 1 and 2, and it's always sending these full updates, even though they're probably totally unnecessary. This isn't that much overhead with DTP. But it is a little bit of overhead, and frankly, as we're about to talk about, it may be overhead that you don't want just because you don't want the overhead, but there are other reasons for turning DTP off. Now, one of them, when a port is configured as an unconditional trunk port, there's no need for that same port to be sending DTP frames. And if there's a device on the other end of the point-to-point connection that literally can't trunk, let's say you have a switch port connected to a firewall, or you have a trunk port connected to a network analyzer. Well, if you can't form a trunk, why send the trunking negotiation protocol frames? So there's a little bit of overhead there we could cut out, and of course we're always looking to lower the overhead. And those are solid reasons to disable DTP, but let me give you a much bigger one. That's very important stuff here. Leaving DTP running on ports that aren't actually trunking is a huge security risk, because what happened here when I just plugged another switch into a switch, trunk came up just fine. Well, I might not want that, because leaving DTP on in this situation, it makes it easier for an intruder to introduce a rogue switch to our network, a rogue switch that looks like a legitimate part of our network, and maybe no one notices it, but it's under the intruder's control, not ours. For this reason, it's really a best practice that you disable DTP on all your switch ports and trunking mode be set to unconditional trunking, and that's it. Now we are going to do just that in the very next lab. We're going to start with switch 1. We're going to run into some real-world issues, especially there's one you see on the screen there. We'll see some others, but on the very next video, we'll run DTP, we'll cut it off, we'll verify it, we'll run switch port no negotiate, and see what happens on real-world switches. See you on the next vid.